Okay, I think we are okay. And these are the kind of things I should do before I go live, but technology's unlimited. So, at any rate, we're going to jump over this introduction and go straight to a shared screen, I think. And we're going to start out with a live view of Saturn, and that's where we are. And let me. Okay. Trying to fix this where I can see any comments that might come up. I have checked outside and the skies are looking pretty good. There's a couple patches of clouds that uh, may give us an intermittent pause, but I intend to stay with this until I either get enough images or I don't. I'll show you what I took last night. I think I can do that. Let's go to Astro and let's go out to 2002 September planets, and this was Saturn. The same Saturn you're looking at right now is the Saturn I took last night, and I don't know where I put Jupiter, but this is the same Saturn that we took last night that you're looking at right here. I rotated it and put it in the angle that we see it through a telescope, and ran it through different processing software, and that's what we're looking to get again tonight. So this is our game plan right here. And we'll minimize that. I come back and look at it, and we'll go back to our live view of Saturn. Isn't it amazing that here we go. Isn't it amazing that we can sit here in our homes and get this kind of a signal from this planet? Let's see how far away Saturn is. Let me bring up this software here. So you are looking live at probably the most known planet of all the planets because of its rings. Almost every child in elementary school, when asked to pick out the planets, will know Saturn. It's even called a romantic planet. I don't understand that, but I'm having to type with a here it is right now. Saturn is right here. Jupiter is right down here, and it gets a little higher in the sky. We're going to take a trip over and see Jupiter, but for the time being, let's get some information on Saturn. And let's see. It's 1350 million kilometers. From Earth. It's the sixth planet from the sun, second largest. It's a gas. It's a gaseous giant like Jupiter. And Saturn's average distance from the sun is 9.5 times that of Earth's. Takes 29 years to complete one orbit of the sun. It's 74,130 miles in diameter. Earth is about 12,000 miles in diameter. A day on Saturn lasts 10 hours and 39 minutes. So, like Jupiter, it rotates very quickly. And so you have to knock off your images fairly quickly, and you have to derotate them in order to render a good image. And that's all driven by software that's been written, most of which is free, by other astronomers far smarter than I. So let's go back and take a look at this magnificent planet. A long, long, long distance from us. I'm also imaging outside. It's going to have to connect. This large telescope here is the one that's on Saturn right now. This wide field is imaging the Veil Nebula. And let's get over there and see it. And this is what I started imaging about 30-40 minutes ago. And so I've got data already coming in. This is what it's looking like. I was able to take 40 hydrogen alpha filtered images and 40 oxygen 2 filtered images last night, and I'm taking another 40, or a total of 80 images, and they're 240 seconds long. They're 4 minutes long. Also last night, I've already taken them. I don't need any more. I took some 10-second red, green, and blue. These will make up the star field. And I'll remove the narrowband star field from this image, and I'll use these stars instead of the narrowband stars. They'll be tighter and render a more natural starlight than the narrowband. And I'll just remove the stars from the narrowband image in post-processing, and I'll remove the stars from the star image, RGB combined image, and I'll just I'll delete the stars from the narrowband as they're no longer needed. And so they have the same geography, the same dimensions, so it'll be pretty easy to, it'll be really easy to stack them. In the right place, or register them is what we say. I've got the camera cooled to minus 15 degrees Celsius. And guiding's going pretty well. I don't think it's great. I haven't really looked. It's at 0.85. And my RMS is 68.68, and my DEC is 0.55. These two numbers need to be close, whether they're high or low. They just need to be close to each other to have round stars. If one of them is larger than the other number, then they're oblong stars. So the telescope moves in right ascension, and in theory, it should not move in declination. Once you if you're correctly polar aligned and you lock onto your star, then right ascension should be the only direction that the mount is moving in. But that's not always the case, and it's not the case with most consumer mounts. And the red line indicates the movement in declination, and the blue line represents the movement in right ascension. You probably can't see it, but there are pulses being shot to this mount. There's a star that is centered right here that this software has identified as being the best guide star in this star field. And this software's job, it's called PhD2. It has one job, and that is to send signals, pulses, to the mount when needed to keep the mount centered on this guide star, which in return will keep the mount centered the telescope centered on the target. So it's nudging the mount. These blue lines going up and down are pulses that are being sent by software to the mount and correcting the mount. For example, it's going in this direction, it sends a pulse, and now it's going in this direction. And then it gets going in that direction, it sends a pulse, and now it's going back down. And there's pulses being sent in declination as well. All of this is trying to keep the mount pixel on pixel, or keep the telescope pixel on pixel, which means keeping the mount pixel on pixel. So we're dealing with what's called an image scale, which comes from calculating the pixel dimensions of a camera as it relates to the telescope. And so this particular combination has a pixel scale of 2.32 arc seconds. And with that, I could, in theory again, I could guide up to 2.32 without having two seriously nutsy looking stars. So you really want to keep your RMS, or I want to keep my RMS as low as possible. And as long as I'm under 232, I can use the images in processing. But these two numbers need to be pretty close. If I have a high RMS, and these numbers both then would be higher, as long as they're the same, my stars are round. The larger they are, though, the more bloated my stars will be. And that's one of the reasons why I take those short exposure stars, because by adding these 10-second stars, not a whole lot can go wrong in guiding over 10 seconds. And so these stars are a lot tighter. Let me go over to let me make sure Saturn's still in my field of view. Yep. Okay. And for those just joining, we are also live imaging Saturn with this. This is my observation camera outside, and this Smith Cassegrain is on Saturn, and the stellar view wide field is on the Veil Nebula. And this is the data so far that's coming in on the Veil Nebula. Now I'm going to go to some post-processing software called PixInsight. And this is what I took last night. This is what the stars look like that are 10 seconds long. So you see how nice and tight they are? They're real precise. And so they're not bloated. they're round. And then here is a 240-second oxygen 3 filtered stack of 40 images. 40 images were stacked to make this. And this is the hydrogen alpha. A lot more signal in the hydrogen alpha. And when you go back and forth, you can see that very easily that there's a lot more signal here. Now, what I want to do is get twice as much signal by imaging tonight. And as you can see, I don't have enough blue. This is oxygen 3 is going to show blue. And so I don't have enough of that right now. Let me combine this. I'm going to take, I'm going to minimize these. I'm going to put back where they belong. And I'm going to drag the hydrogen and I'm going to put it right here. I'm going to drag the oxygen and I'm going to put it right there. Whoop, it didn't go. There it is. And I'm going to drag oxygen and I'm going to put it also in the blue channel. And I'm going to make a color image. And here it is. It's going to take it a second to compute. So this is the color image. It needs to be cropped because of these stacking artifacts at the edges. And I need to run a dynamic background extraction, and I'll do that real quickly. And that'll kind of eliminate some of the gradient and also eliminate some of the vignetting in the corners. The algorithm is set to perform a division. Let's re-stretch this. I'm using division down here to remove the gradients that are due to pollution, light pollution. So they kind of went away, or some of them. And then I'm going to use subtraction. And I'm going to apply this again if it'll let me. No, I'll have to shut it down and then open it back up. And now we're going to try subtraction. And this will remove some of the vignetting that I have in the corners due to optics. Light pollution will create gradients. Your optical train produces its own nuisances and gradients, but they're more, there we go. So we've kind of removed those now, which is pretty good because it gives us something to work with. The color needs to be calibrated, but you can see some of the pretty blue. It's kind of a teal colored that's going to be in this image once it's color calibrated and the noise is removed. So pretty cool, and that's what we're imaging. I need more blue, I need more red, and so that's why I'm back out here getting, there's the image again. I'll stretch it, but it is, this is what we're looking at as it's being taken live. So we're at image 51 in hydrogen alpha out of 80, and then I want 90 total. I want 10 more oxygen. I have 5 hours of imaging time remaining, and I took about 6 hours last night, 5 hours last night. So when it's all said and done, the one image will have an investment of around 11 hours of total exposure time. It just takes that much time to capture enough photons that have been traveling for millions and millions of years. In fact, let's see how long it's been traveling. Let's go back to let's type in NGC 6974. That's it, isn't it? I think that's the Veil. Yeah, here they are right here. The Veil Nebula. And let's see. I'll read. It says, these glowing gas filaments are tiny sections of the Cygnus Loop supernova remnant. So that's what's left after a supernova explosion. It's a 5 to 8,000 year old supernova blast wave that plows into gas into the interstellar space at 170 kilometers a second. It's 6 times larger in diameter than the full moon, and normally it tells us how far it is. But it isn't. So there's no more information on it. Okay. Anyway, we'll head back out. We better go check on Saturn to make sure. Okay, good. It's staying pretty centered for me. I'm going to try to adjust the focus a little bit. I want to come back out to thousands. There we go. I'm going to start imaging this in a few minutes, and I'm going to set this up to take a series of images. And in fact, let's go ahead. I was waiting till it got just a little bit darker, and my plan initially was to go live at 9:30. That's when it's nautical dark, and but I went ahead just because I had a fear of clouds cutting my night short, and I wanted to share with you folks what I've been doing the last few days during these rare clear sky summer nights, and they are rare. I'm also imaging, as I mentioned, the Veil Nebula, and here's what's coming in. These are 240-second images down here. I hope this shows up on YouTube and Facebook, but we're at 25 seconds and counting left in this exposure. And once this particular event ends, when we've completed 80 pictures, then it will automatically rotate down to the next. It'll add a new filter. Right now we have the HA filter on, and as soon as it it goes to the next event, it will automatically change the filter and refocus automatically the telescope with the camera, and we'll be off and running, taking 50 more, hopefully, O3 images, which will be the blue in this particular nebula. And I will go back and forth because we have people looking in and not necessarily staying and wanting to know what's going on. But this is what I took last night. All I did was run a dynamic background extraction, both using subtraction and division on the veil. I combined them using channel combination, and it's the HOO palette. So I'm not taking any sulfur. There's not a whole lot of sulfur in this image. It's mostly hydrogen gases and oxygen gases that are the result of the supernova blast that took place between 5 and 8,000 years ago. And we just read that. And that's why I know that. And before I read that, I did not know that. This is a terrific hobby if you're puzzled about what's up, how long it's been there, and it just absolutely leaves me almost dumbstruck to think that when the light left this part of the universe, the world, when the light left this, um, it may have been long before the birth of Christ, and I'm just now getting it. That's how far back in history we're looking. And there's some uh, star clusters, globular clusters, that are billions of years away. And if you want to know how long a light year is, I'll put it to you the way it made sense to me. The speed of light, 186,000 miles per second, a light beam can travel around the Earth at the equator 7.5 times in 1 second. That's how fast that photon is traveling. And if it can move around the Earth's diameter 7.5 times in 1 second, how far do you think it traveled in a year, that photon? And then how about hundreds of millions of years that it's been going through the void of space? And then it fights our ugly atmosphere, and it finds Ed Overstreet's sensor in his backyard on a consumer-grade telescope with a consumer-grade camera and a very limited knowledge of astrophysics and science really in general. That's just crazy. Terrific hobby. And you can do this in your backyard. You can share it with your children, your grandchildren, friends and neighbors. All like to come see what I'm looking at. Okay, we are having some fun going back and forth between Saturn, and let's go take a look at Saturn. Here we go. It's beginning to drift, and which is okay. Tell you what, I'm going to start imaging. So let's go ahead and let me boot up PhD. I want to stop this horrific guiding, but part of it has to do with I'm guiding on one of the moons of Saturn, and it's not a real good, it's not the best, it's not a guide star. So let's go back out to Saturn, and what I'm going to do is I want to recenter my crosshairs. No crosshair and single crosshair. And let's see, I want to move a little north, and I'm going to go up and set up a capture. This is going to be Saturn, and I want 5,000 frames, and I want to do 10 images, 5,000 frames, 10 video files, 5,000 frames long, and then I will derotate these in PixInsight, not PixInsight, WinJupos. WinJupos, WinJupos, is software that is sophisticated in that it can calculate the rotation of Saturn as it rotates completely once every 10 hours. And if you take 10 5,000 frame video files, you're going to be imaging for probably 15 to 20 minutes. And during that time, Saturn is rotating. And if you try to put those together, you're going to get a blurry Saturn, even if your focus is tack sharp. So you have to derotate Saturn, and so that you can register and stack these frames one on top of the other in precisely the right place. And this is amateur software written by amateur software writers that love astronomy. And that just blows my mind and makes it available for less talented software programmer type people, of which I am not. It's as good as I can get just to figure out how to use it. So we're going to start, and we're off and running. Down here it tells me we're capturing frames, and so the game is on. Now while that's going on, let's head over to, oh, by the way, I'm asked, why don't I guide when I'm imaging? And when you guide, you will keep your image, you should keep your image in the crosshairs. However, if the image starts to wander a little bit, then it sends a pulse and it jerks it right back into the center. And that jerking motion doesn't stack real well when you start stacking these AVI frames. AVI is a movie, what is it called? It's like an MOV AVI file. They're just movie files. It's got a name and I can't think of it. But at any rate, I lost my train of thought. It's time for more coffee. That wakes me up. Okay. Still don't remember. And it's probably unimportant. So we're at right now about 2,000 frames. It's kind of a video, if you will, is taking all of these frames, one right after the other, are actually still pictures, and it puts them together so fast that it's a moving picture. And that's what's going on here. But what I want to do is separate that moving picture back into those frames so that I have all of those separate 5,000 frames. And then I want my software, which is AutoStacker, to take 5,000 separate images and stack them on top of each other to make one TIFF file, one large single image coming from this. And I'm only going to keep between 10, 15, 20, 25% of the 5,000 images. So I may not keep but 1,000 of those frames to make that TIFF file. I want to keep the best of the frames. And as you can see, Saturn is moving around, and that's due to atmospheric dispersion between my camera and Saturn. And it's the atmosphere that has thermal movement and winds, and all of that has an effect that causes stars to twinkle and the planet to look like it's underwater and kind of undulating. And that's just, we call that seeing conditions. And the more it moves and wobbles and loses its form, it's attributed to what's called poor seeing conditions. And the transparency of the sky, the humidity, the heat coming off of the rooftops, all of that is kind of creates thermal issues, and you have to shoot through that. So that's what we're trying to do. I'm getting too much drift here. So I'm having I think I have 20 seconds between images. So when as soon as this finishes 5,000 frames, I've got a few seconds before it's going to start taking another, and I'm going to move this down. So I'm going to have to somewhat babysit this, and that means I'm going to have to move it south and east, and now a little west. Come on up. Oh, lost it. I'm going to have to stop this whole thing. All right. Oh, I got too much. I got to change this. I'm at 2 times sidereal. I need to be at 1 time sidereal. Oh, I've lost. Let me shut this down and bring up my. For some reason, our Wi-Fi signal outside is not as good as. I'll reconnect to. I hope I haven't lost Saturn. I hope I haven't. There we go. Oh, we lost the connection again. Yeah, this stuff happens when I'm live. It's 3 minutes and 34 seconds before the next capture, so I don't know. Your network is experiencing poor performance. Let me see. I can't even. Well, let's go over and see if the other one's having a problem. Are you kidding me? All right, let's head over here. Let's try again to. Well, we've got Saturn back. Now let's try to move it up. Let's change this to 1 times sidereal. Come up. West brings it up. It's just not moving. I'm not guiding, am I? No. Okay. That's good. Let me see. All right. Saturn's locked on. Let's go back out. Well, we're back. Let's move it south just a little bit. Let's come back up west now. And south again. That did it. Now let's bring it up. I'm going to go ahead and cancel this. We're going to start this again. And this time we're going to have just 30 seconds between capture, and let's start all over again. I tell you what, with this drift, I think I am going to guide. I'd rather deal with the bump than to have all that drift. And let's move our speed up to exposures to 3. Okay, we are now guiding. All right. And let's go back outside. We're now capturing our second image. We have one 5000 AVI file, 5000 frame AVI file, and we're working on our second one. And this time we're going to have, instead of 5 minutes between pictures, we're going to have 20 seconds. So I've got 20 seconds to recenter, but I'm now guiding, so I shouldn't have to worry about it. I'll just have to worry about the jerking that takes place. So let's head back to our other one, make sure we didn't lose. Let's see, we want to go to number 2, and let's see what one we're on. We're on 56. We have 36 seconds, 34 seconds remaining in this exposure. And this is the Veil. And as I mentioned earlier, if you're just joining, last night I took 40 HA and 40 O3 images. They're 4-minute long images with a wide field stellar view 70 SV triplet refractor. Guiding is decent, good. It's 0.67 RMS total, and my stars are going to look pretty good because I'm at 46 and 48, and that translates into a real good half flux radius, which is 0.83, and that's great. My mean is right where I want it. Even though I'm shooting over the city of Spartanburg, I'm shooting narrowband, and light pollution doesn't create as big a problem for narrowband filtered light that it does RGB light. So I'm still dealing with a mean in the 1600s, and that's pretty cool. That is real cool. Because I've been up at 5,000, 6,000, 8,000. That isn't cool. And if I were shooting RGB, I would be 3,500, 4,500. But we're in narrowband, not broadband. And in fact, when the moon's out, I won't hardly ever image with a one-shot color camera or in broadband. I'm either going to image narrowband, or I'm just going to star jump and go look at places in the sky and not image at all, just jump from place to place and read about it and maybe take one picture of it, stuff like that. And I'll tell you what I really enjoy doing. Like I image some of these over and over every year. All of these targets are cyclical. In 3 or 4 months, you probably won't be able to image the Veil Nebula because when it gets dark here, it's going to be way past the meridian, and there won't be enough imaging time to fool with it. And you'll have to wait to next year to do it again. So I like to compare what's going on from one year to the next and take this particular finished image and compare it to the Veil that I took, say, 10 years ago. And so it's fascinating, to see if there's any movement, any star movement that are stars that aren't here that were there. And and when the clouds are hanging overhead and you can't do any imaging, that's when it's time to reprocess your old data and compare data from 1 year to several years ago, and most of the time it's exactly the same and there's no change. Every now and then you think you've discovered something, whether you have or you haven't. You think you have. Okay, we'll head back over to Saturn, and I don't know why I have to do this to go from one to the other. Let's move this over here. Let's move. This is. I just got started. I just got started just a few minutes before. Well, actually, after I came online, I went ahead and combined the HA that I took last night with the O3, and I combined it using H I mapped H in the red channel, and I mapped O3 in the green channel, and I mapped O3 again in the blue channel. And that's produced this image, and then I just ran the dynamic background extractor to eliminate the gradients, and that's what we're looking at now. The images, I'll start all over when I start processing this, and I'll just delete all of this because the HA and the O3 I won't be using. I'll have a new HA and a new O3. That's a lot more data because I'm collecting it again tonight. But I just wanted to see if my framing was going to be okay and exactly what I was going to be looking at, but I can tell that I need more blue and I need more red in order for this to be something I'm really glad I took and proud of. It's really kind of cool to see that what we're looking at are remnants of an explosion that took place between 5 and 8,000 years ago, when there was a supernova blast that blew all of this in the sky, and the distance from one end to the other is larger than 8 moons put side by side. So it's a pretty good swath of the sky. What is our moon doing? That's not our moon. There's our, not our moon. Our Saturn's doing. Am I losing my mind? So we're looking at Saturn. It's we're having another capture. We're at 3,600 frames. This is probably the third capture. I know I have 2 captures. I'm going to check and see something very quickly. You're going to see a blank screen. I'll be right back. No, you're not. The resolution is, can you, with your YouTube video, Mike, if you'll go over to the gearbox, you can change that to 1080. You can change on YouTube the resolution to 1080. And if you're at 144, I know you can't see anything. So if you're watching this on YouTube and I have one comment telling me that he's at 144, then at the bottom right of your YouTube, the YouTube whatever, where you have your little, let me see if I can I don't even know how to get to it, but at any rate, there's a gearbox type thing. Click on that and you can go up and select 1080. So I apologize that you're having a hard time seeing that. If you have any questions, where I can see the comments, the questions from Facebook and the questions from YouTube should come in one comment section. And if they don't, I don't know how to fix that. I just know my software, when I simulcast, and manufacturer of the software has pretty much guaranteed that you don't need to see me. Let me get rid of me. There we go. I apologize, guys. We want to look at Saturn. So we're looking at Saturn, the most widely known planet. Mike, if you're still online, did that fix it? And I don't know about Facebook, but Facebook, I don't know. I don't know if there's the same control, but you do want to be watching this in 1080, and it is set up for that. It defaults, I think, to 720. But you're right. If you're watching this in at 144, then you can't see anything. We'll add a little music and the mysteries of the night. We are currently imaging Saturn. We're taking 5,000 frame AVI files. So we're taking video, and each video will consist of 5,000 separate frames. I plan to keep about 20% of the very best of those frames and stack them into an image using software called AutoStacker. It is free. And once I have it stacked, I'm going to take that image into Registacks. And last night I took some of these and I took them into Registacks, and I got this image. So this over here is what we're imaging right now, the Veil Nebula. And this is the Saturn that I took last night with an 8-inch Smith Cassegrain, and attached to that is a 2.5 times Teleview PowerMate, and I'm using an ASI 224 planetary camera to make an image like this. So let's head back out, and we're about at 5,000 frames, and we've taken 3, 7 are remaining, and 23 seconds until our next capture begins. This software I'm using is called SharpCap. The basic version is free. It's $15 a year if you want to buy the Pro version. It's a no-brainer. It has everything you would ever want in acquisition software. I can control my mount from here. I can control my electronic focuser that's outside. I'm probably a good 30 yards from my telescope. Inside my house, as far away from my telescopes in my backyard as I can be. I'm in the front of the house. The telescopes are in the back of the house. Now they're kind of up on a hill, permanently attached. In fact, this is what's out back. And it's connected. The Smith Cassegrain is locked on to Saturn, and this is locked on to NGC 6974, which is the Veil Nebula. It's going to be doing a meridian flip in about 30 minutes, which means that this telescope is going to cross the meridian, which is, with this particular target, at the zenith. And it's going, the weight, if I didn't flip this mount, then these weights would end up being higher, and this telescope would run into the pier. So what's going to happen is that software, I won't do anything but watch it happen because I have it set up to do just that. This software is going to run my telescope 10 minutes past the meridian, because that's what I elected. And then it's going to flip. The telescope is going to come over here on this side and look up, and the weights will be on this side, and the telescope will be going up instead of down. And it'll finish in right ascension imaging. It will automatically recenter on the target within 50 pixels of where it was before the flip, because that's what I set up in the software. And most of the time it's within 10 pixels. And it will refocus. It will start PhD guiding back up again. It will monitor the guiding, and when it's settled and it thinks it's safe to start imaging, it will start imaging again. So I could go to bed right now and it will finish taking those pictures if clouds don't stop things. And if clouds come over, and block the view of this guide camera, this guide camera is going to send a signal to the mount to park it. It's saying, guys, you're wasting your time, no point imaging, park it. And it will park the mount and turn everything off. So it's pretty neat stuff. This is a cover over my solar setup. I have a solar telescope with a Daystar Solar Scout, and then that sits on top a refractor, an Astrotech 65 EDQ, and attached to that is a quark chromosphere, a hydrogen alpha filtered sun solar kit. And then I use a ASI 174 camera to image the sun. And I hope to image the sun most of tomorrow morning, taking a time lapse because there's some cool stuff going on. I'll probably be live until church starts, and then cutting grass. Yeah, I know, cutting grass. Okay, we're about to finish 5,000 frames, and I think we'll have 6 to go. Yep, 6 remaining, 28 seconds in this run. And let's head back over to our other telescope, the Stellar View Wide Field. And we have 50 seconds left in frame 61. Guiding is going good. My half flux radius is still around 86. Under my image history, my HFR I have a low of 83, and my last was 0.86, and that's excellent. And part of that reason is because my guiding is under 1, and my star and my deck and my RA numbers are pretty close. Although they're fairly far apart here, it's 16 arc seconds apart. They're close enough to keep round stars. I like it when they're both within 3 or 4 arc seconds apart. The best, and that's when I get my best, absolute best stars. And for imagers, having round, sharp, tight stars only tells me that my data collected for the image is going to be detailed and as good as possibly I would be able to ever get. So as good as this is, my target will reflect that. And this whole camera, let me go outside. This camera right here on top is the guide camera, and that's a guide. This is a guide telescope, and this is the guide camera. Here's another guide telescope, and there's a guide camera, and it's taking pictures. And what you're seeing from this little telescope and this telescope, what you're seeing is this. It's taking a picture every 1 second. I've got exposure set for every 1 second. It's taking a picture of a star, of this star right here, which you can't see. This is my guide star right here. Here it is also right here in these crosshairs. These are other stars that are also being used to help keep this on track. And these lines up and down represent pulses that the software triggered to the mount to make a correction in the mount. So the mount, which is the motor that drives the telescope in right ascension with the Earth's rotation, is sending corrections so that my target can stay pixel on pixel, so that there isn't any drift. And now something happened outside. My guess, a bird or something landed on my telescope. An online friend, Chuck Ayub, had squirrels that got in on his mount at night, and his observation camera showed that. So this was probably image number 5. Image number 5 is probably going to have a lot of issues. So I may end up deleting more than, I may only keep 15% of the frames. That's why I don't keep all of them, because there are issues with some of them. And as you scrub through them, you can see those issues. So AutoStacker, the software that does the stacking of the movie files, will tell me, it will recommend the number of files I should keep, and of course the ones and it will automatically do that for me. It'll pick the very best, the top 10%, 15 or 20, whatever I tell it I want it to keep. When I first started doing this, I kept 100%. I thought, well, why wouldn't I want to keep 100%? Well, after you process it, you do see you get a better image by only keeping the best. So this is our Saturn, and we have 5 remaining, and as soon as that's done, we're going to Jupiter. And we're going to spend some time imaging Jupiter. And this, on the other hand, is going to run almost all night. I have 4 hours and 32 minutes left to take the balance of the hydrogen alpha and the 54-minute oxygen 3 filtered images. So right now it's 10. So at 2:30, in theory, 2:30 would be when it stops, but there's a pause between images, as I've instructed the software has instructed the mount to dither, which means it's going to automatically move the mount a few pixels between images. And what happens when you do this is that the stars move when you move them out. The stars move, but the crap that's on your sensor doesn't move. So if you've got dust and stuff that's on your sensor and you move the mount, well, the dust moves with your mount, but the stars, they they don't. The stars move and the dust doesn't. So software says, well, the dust must be removed. And so when you dither, you know what's bad and you know what's good, and software removes the bad. So it helps to eliminate the crap that collects on your optical train, dust and whatever, debris. It just gets in there. They stay outside. Mine stay outside 24 hours a day, 365 days a year. I cover them up with astronomical covers called telegizmos, and they protect them. And we've had tornadoes, hurricanes, snows, freezing in the teens and in the hundreds, and they just keep on ticking. Our homeowners association, when we moved here, would not allow outbuildings in our neighborhood. They now allow them, but they have to have the same roof as your home, same siding as your home. So I'm pretty much limited in building an observatory in my backyard, a physical building. And at my age, it's not practical. I'm in my late 70s, so it's not practical to spend that kind of money on something that the number of years I would have to use it, is, hate to say it, but I'm going to get to see some of these targets live and in person in the not too distant future. I hope it's distant, but we don't have leases on life, do we? Okay, so we're collecting this. Hopefully, when we collect that, we're going to have a lot more of this. This came from last night. I just wanted to see what it looked like. So I just combined them to take a look. There's been no processing at all. Just combined them using the HOO palette. And that's what we've done. Now, back over at Saturn, we are about to take another 5,000 frames in one video, and I think we're going to have 4 left. I'm taking a total of 10. 4 remaining, so we've taken 6. This is going to jerk it back. The guiding software is going to jerk this back in a minute and put it in the crosshairs. That's what I try to avoid when I'm imaging planets. I can guide, but the pulses that are sent can and will cause a jerk to move this back. I wish I could figure out a way to write a script, because I understand you can do that, where it only makes a PhD correction during a pause between captures. Bill Blanchard, if you're listening, or if you later listen, Bill wrote the software that reduces stars in your image. He's a brilliant software writer and a subscriber to my channel. And Bill, if you do watch this, and I know you're a SharpCap user because you sent me a message about that, what I want you to do is figure out how we can write a script in SharpCap that, when imaging, will allow me to guide but not send any corrections to the mount until we are at a pause. Is that possible? And if anybody could do it, Bill Blanchard can do it. He's one of those folks that, by the way, I'll show you his most recent. He wrote the star reduction methods over here that are used by PixInsight now. They're brilliant. Some of these stars need to be removed from this image. It not only removes the stars, but if I have bloated stars, it'll remove the star size. So if you're, and these are free. These are free to download and install in PixInsight. So if you're a user of PixInsight and you haven't gotten Bill Blanchard's scripts, you need to scroll down my videos. Oh goodness, it's probably 10 or 15 videos ago where I'm talking about doing videos on star reduction, because I have links to his software and how to download it and how to install it in PixInsight. Let me go back over here and see if all right, let me try that again and do it this way. Yeah, okay. So we're watching these frames get knocked off. Still hadn't made that correction. There it goes. And it wasn't too bad. It moved it down some. How'd I come back? Hey guys. These earphones are so hot, I'll take them off. But then if I do, I end up getting another echo. I won't know it. Oh, me. Um, it is so cool to be able to sit in my little cubbyhole of a man cave. I call it the Overstreet Observatory. Sit here and have my telescope beaming on three more remaining, beaming on Saturn. If you're just joining, make sure that at the bottom right of your YouTube channel that you select that little gearbox and you pick 1080 um, resolution. If not, I understand you're going to be either at 720, and Mike was at 144. So there's no way he could see anything. Ooh, Saturn's moving on me. That's fine. I can still stack that, but I wish it wasn't there. I'm tempted to stop it and take the last 2 frames after I've recentered it. I think I will. So it's at 700 frames, and when it gets back down to, or when we get to 5,000 and we get to a pause, well, it's moved it back. Yay, without having to do anything. That's the guiding software sending it back. Well, we've got a long time before that, so let's head over to the Veil. Take a look. Get a high stretch, and there's the data. That same data is what you're seeing right here. And I took it last night. I'm going to add more to it, reprocess everything, and I'll let you know how it turns out. I'll probably make a narrowband processing tutorial, or I don't know if you can call it a tutorial. It's just how I do it. And I've pretty much gotten everything I know in processing from watching other people do their YouTube videos. Warren Keller, Adam Block. If you're not a subscriber, if you're an astro imager and you're not a subscriber to Adam Block Studios, then and you're serious about processing your data, then you need to invest in Adam Block Studios. It comes with a cost, very affordable, and also IP for AP. Warren Keller, Ron Beecher, and Peter Prolak have a powerful set of tutorials, and they put on virtual classrooms now since COVID has pretty much driven much of this to be virtual. But they put on 1 and 2 hour classes where you can ask questions and so forth. They mostly picks insight. And Adam Block, though, is an astronomer. He is an astronomer. He's a software writer. He's on the Pix Insight team, and he knows the software inside and out. But he's also a guru with Photoshop, and Photoshop's really my strength. Being a photographer, I've been a Photoshop user since the mid-90s, and so I'm very comfortable doing everything just about I do in Pix Insight I can do in Photoshop. It's a more laborious challenge to do some of the things in Photoshop, but there isn't anything that's being done in Pix Insight that can't be done in Photoshop. Pix Insight just made it so much simpler to do it. I still, though, finish most of my images in Photoshop. The heavy lifting is done in PixInsight, and then I go back to Photoshop. All right, let's go over and see if we have, we already finished it, and we got 14 seconds to the next one. So we have 2 remaining. I'm going to hit cancel. And let's see, we need to go east. And now we're, why are you going up? Oh, it's because I have to stop PixInsight. Hang on a minute. PixInsight's making a correction. So I need to stop this. Well, guiding is horrific. And let's go back to SharpCap, and let's go back down west. No, we want to go east. And that's good. Right there is fine. Probably north would be a good nudge. No. Yeah, we got to go. That wasn't smart. Got to go up again. Okay, stop it. Now let's get PhD back up. Let's start guiding. And I'm going to change this now to 1 second. And make more frequent corrections, and they might not be as radical, because I'm not chasing scene conditions right now. All right, let's go back to our Saturn image. You're looking at a live view of Saturn, one of our favorite planets, and we're going to be taking, we've taken 9, we're going to take, I'll tell you what, let me go ahead, we've got 8 in the can, let's go to Jupiter. What do you say? Let's go down to guiding, let's stop the guiding going on, and let's bring up our planetarium software, and we are right here with Saturn. Let's select Jupiter right there. In fact, let's just go bring Jupiter up, and let's bring up our outside camera so we can see it happen, and we'll get that going. It's connected, so let's go back to where are we? I guess it's right here. Let's go to the no, we're on PixInsight. Where's Saturn? Right here. Okay, let's go back to Cartez, and let's slew to the target, and you're going to see the mount is moving, and let's go outside, and oh, there it goes. So it's moving over to Jupiter, and Saturn was over this way, so we should be pretty close. I screwed up the sync in this, and so let's bring up PhD to, and let's start looping again, and there's Jupiter and one of its moons. Let's we'll look at all of his moons. Let's bring up about 1.5 seconds, and let's bring up 2 seconds and see if we can, or 3 seconds. Exposures. Yeah, there's one moon, there's another moon, and these are the moons of Jupiter. And there's one right here. It's way on the other side, but I see the nudge right there. So let's go back down to, say, 1 second. And let's move the mount. We need to go up. So that's going to be west. And here we go, loop-de-loop. Do-do-do. Let's go north a little. I'm going to move it that way. And let's go back west. And we're just going to hold it down. Let's go north a little more. And now let's go west, and we can go over here and just hold down west and wait for it to come into the picture. Actually, let's do this. Let's go back to the native resolution. And now let's go west. And it should come in from over here. Should. Here's one of the moons coming up right here. This is one of the moons of Jupiter coming up. It's funny. Here's another one of the moons. I love it. There it comes. Big time. Oh, love Jupiter. Okay, let's dial down the gain to about 200. And 35, let's dial down the resolution, the exposure to, let's come up a little bit. And we really don't look like we have a very decent focus. Let's play around with that. If you're wondering why I haven't rotated my camera so that it needs to be rotated about, let's see, 120 degrees so that these bands are kind of like this angle. So I need to go out and rotate it 110, 120 degrees, and but I haven't. I'm going to try moving the focuser out 10 steps, just looking to see if I have any sharper. And I do think one of the problems when you image with a Smith Cassegrain, the big tube, there are no lenses, they're just mirrors. Those telescopes are just mirrors, reflecting mirrors. And the tube itself cools down from being hot during the day. Yeah, I'm getting a better focus. And I wish I'd have done this on Saturn. Oh, yes, I do. But at any rate, they're hot, and then they cool down. As they cool down, focus changes because it expands and contracts with the temperature. So your focus doesn't stay the same overnight. As a matter of fact, let's go ahead and set up some imaging here, and let's move up just a little bit. West, 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 and let's move over south, south, and then west. And let's bring up PhD, and let's start looping, start guiding. This isn't going to go well because I'm guiding on one of the moons and it won't go well, but it'll be better than doing nothing. Stephen, glad you subscribed. Welcome. If you have questions, let me know. So our guiding is taken off. Let's go back and look at or go back to Jupiter, and let's okay, let's see, Jupiter. Here we go. And let's start setting up a capture. I'm going to go to capture, start capture, and we're going to change this to Jupiter. And we're going to take 10 images 30 seconds apart, and we're going to do 10,000 frames on Jupiter. And this definitely will have to be derotated using WinJupos. So we're off and running. And down here at the bottom left, you can see where we're capturing. It's a slow frame rate, 25 frames per second. But it is what it is. And let's head back over to our other telescope. And if you're just joining us, these two telescopes right here are doing the work. This is on the Veil Nebula, and we're currently capturing, waiting for a meridian flip. In fact, you're going to get to see the meridian flip. Let me go to the software and you can see it happen. The software is, let me see when it's going to flip. I'm going to go up here and I'm going to click right there, go to planning tools, and it's going to transit at 10:43, which means in 15 minutes it's going to transit. But remember, I said that I've got this set up to go 10 minutes past. So if you go to the control panel and you go to your telescope where it says telescope options, use auto meridian flip, and when I set this, I have it to wait for 10 minutes past the meridian. And the reason why I wait is because if I just if I flipped right at the meridian, this is going to try to plate solve. And it can't move the telescope but opposite the meridian. If you're right up against the meridian, it can't plate solve if it has to move east. It can only move west. So you want to give it some movement room. You want to give it some wiggle room. If you wait 10 minutes, then it's cleared the meridian far enough that it can make corrections to center your target, moving either east or west or north or south. But if you try to plate solve immediately at the time it hits the meridian, which some people do, they wonder why their plate solving fails. Just add 10, 15, 20, 30 minutes to it. You're not going to cause any problems. Your mount could run an hour after a flip, after the transit. And for example, let me go back outside. The weights are pretty high because it's getting ready to flip, where the telescope ends up on this side and the weights end up on that side. If I didn't, then the telescope would keep going down, down, down until it ran into my steel pier. And it would tear up the camera, tear up the filter wheel, tear the whole thing up. So that's why I have to flip. But it would take it 2 hours to move anywhere close to this mount. So I could, in theory, go maybe 2.5 hours past the meridian. The weights will just be higher, but this has been balanced. So there's as much weight on this side as there is on this side. This whole thing's been balanced so that it would, if you put it on a fulcrum, it would just be balanced. And it's balanced in RA and declination. So it doesn't take much to drive these motors when it's balanced. So this flip's about to happen, and when it does, the weights will end up on this side, and the telescope will end up on this side. And then from that point, the telescope is moving up and the weights are moving down. And you don't have to worry about your mount throwing your telescope into the pier or moving your telescope into the pier. So that's why you do this was only for equatorial mounts. If you've got an EQAZ alt azimuth mount, then you don't have to deal with meridian flips. It's a different beast altogether. But it's not for imaging long exposures either. So that's what's about to happen. We're about to have a meridian flip, and we'll watch it happen. And you'll see everything stops. The telescope will move on its own, but driven by this software. It will reorient itself so that it's back on the target, pixel on pixel. It'll start PhD back up again. It'll stop PhD guiding, and it'll start it back up again. It will focus again, and it will start imaging again after everything is settled down. And I don't do anything but sit and watch it happen. Or if it's early in the morning when it's happening, I'm sound asleep. The only thing you have to absolutely make sure you've done is secured your cables. Because if your cables are in a position and you're not outside where you can quickly move them, then your cables can hang up on a piece of your mount gear, or maybe one of the azimuth or the alternate azimuth or the EQ, just something on the mount, anything on the mount could catch it. So you have to make sure your cables, of which there are a lot of them, they're all secure and not in danger of snagging. And then you can go to town. So what's going to happen, since I'm going 10 minutes past, what's going to happen with this meridian flip is that when it gets within, say, a minute or two of the 10-minute mark, it will stop imaging and it will say we don't have enough time to take another image before the mount's going to go through a meridian flip. So it'll just stop imaging altogether and wait for the mount to get to the point where it's moved 10 minutes past, and then it will take off. So I want to make sure that I've got my outside camera on and connected so that you can see this telescope make its flip. And this is the big tube. All of these, though, require refocusing after about every 2-degree temperature drop. And I have on both of these telescopes, I don't think you can see it, but right here is a box. And on the other side of this mount is the same box. It's on this one too, and it's called an Ultimate Power Box by Pegasus. And let's go back out and let me bring up. This is the control panel for the Pegasus, and it tells me what the temperature is. And if there's a 2-degree temperature drop, it's going to send a signal to my software to refocus. And down here, the automatic focus run will take place and it will refocus. So the Pegasus has a sensor that's attached to it, and it's on my telescope. It's velcroed onto the telescope. Also, it tells me that I've got water on my, I've got dew problems right now. And it tells me that because anytime the temperature and the dew point intersect, then you can count on moisture on the ground. And if you didn't have dew heaters, they would be there would be moisture on your telescopes. But this is a dew strap. It's attached to the Smith Cassegrain, and this dew strap is on the little guide telescope. So if we go back outside, you can't see it, but that strap's wrapped around here, and this is a strap right here, and this is a strap right here on these two. But this has a strap that's underneath this shield, and then here's a strap on the guide camera, and it's heating this element and heating this camera, which is another reason why you've got to pay attention to your focus and make sure, because this heat has an influence on the temperature inside this tube, and the same thing with this refractor. So now you know. If you're into astronomy, then I'm boring you. If you already do this, you're just being bored to death. I'm sorry. I do know that there are some people watching that will watch this on Facebook that don't do this at all, but are really fascinated, because I talk to them all the time about the planets and the deep space targets and stuff. Oh, we're plate solving. So the meridian flip has happened. Let's go back out, and the telescope, watch here, it's going. There it goes. I've done nothing. So it is flipping. It flipped early. My goodness, it may not be able to plate solve. I'll have to figure out why it flipped early, because it's 10:41 and transit was, well, let me back up. Okay, so we have flipped, and it's going to recenter. So let's go watch our software do this. So it says it is stopping the auto guider. It's performing another slew to center, and then it's going to auto center. It's finished. Now we're going to plate solve. It's setting the lume filter. Let's go see the filter wheel. Well, I can't move it now, but it's put the lume filter on down here, which makes it easier to plate solve because it's a clear filter, so it's easy. You can take shorter exposures. So it's going to recenter my target. It'll be way off at first, and then by the second time it'll work. Now my guiding's already stopped because it automatically stopped my guiding. I'm 1400 pixels off in RA. I'm 535 pixels off in declination. So this next go around, it'll move them out, and I should be right on it, pretty close. So it's running another 10-second exposure. It's going to compare, and it moved it. It did it. So we're going to restart the auto guider. It's plate solved. It's back on the target, except that big star that was at the bottom is now at the top. So it's flipped the picture, which is just fine because software makes that adjustment. So we have a 24-second settle time where everything settles down for 20 seconds before it starts the guider back up again. It started right now, so guiding is happening. It's paying attention to see how the guiding is going. If it's going good, then it's going to start imaging. It did. Imaging again. So we're at setting the HA filter, and so the filter wheel now has moved the lume filter to the HA, and it's now taking the first image with 230 seconds left. And this star that was down here is now high. And in fact, if we go over to Pix Insight, okay, this is the star that is now up here. So it's completely flipped because I flipped the mount. Camera's not in the same place. And this is the image, by the way, if you're just joining, that I took last night. I'm just adding more data tonight. Well, I've gotten sidetracked. I better head over and make sure we still have Jupiter in the middle of the works, and it is. Love Jupiter too. And we're taking 10,000 frame AVI files. I'm going to take 10 of them before the night's over. I'm going to use WinJuPost to derotate them. And how often does Jupiter rotate? How long is a Jupiter day? Let's go find out. Let's move over here and let's find out. I don't know. It's like Saturn, about 10 hours. I think it's even quicker. It really does rotate. And I lost my mouse. Okay. All right, let's see. Jupiter. I don't need mythology and culture. Observation and exploration. Okay. Jupiter's the 5th planet from the Sun. It's 780 million kilometers from Earth. It takes 11 years to complete an orbit around the Sun. See, it takes 365 days for Earth. Jupiter is 11 times the diameter of Earth. It takes 9 hours and 56 minutes to do a complete rotation. So it takes us 24 hours in our day and change. It takes 9 hours and 56 minutes. So what happens when you image a planet like Jupiter, and let's go over there, I'm getting dyslexic on this, is that if I'm taking 10,000 frame files, it takes maybe 4 or 5 minutes to take a 10,000 frame image. And during that time, Jupiter has rotated a little bit. And if I take 10 of those, it may take me an hour and 10 or 15 minutes to do that. Well, Jupiter, if it rotates once every roughly 10 hours, it's moved a tenth of its distance. So if you're going to stack all of those files together to make one intensely signal-rich image, then you're going to have to derotate some of those images because you're taking them during that rotation period. They'd be real blurry just due to their rotation. So you have to derotate them. And there's a software called WinJuPost that I use that does that. Pretty clever stuff. Sophisticated, mind-blowing stuff. To me, it may not be to you. But if you're watching this, it probably is to you too. So you're looking at a live view of Jupiter. And we've just left Saturn about 30 minutes ago. And so with this telescope right here, bingo, right here, we're imaging Jupiter. And we're connecting right now. You'll see them jump. We're imaging Jupiter. And with this telescope right here, we're imaging the Veil Nebula. And we are live, coming to you from my backyard in Spartanburg, South Carolina. And this is what I took last night when I started imaging the Veil. And I took 40 HA and 40 O3 images, plus I shot 10-second red and 10-second green and 10-second blue images. I took 20 each, this will be my star field. These are the ones I'll use for my star field. These narrowband stars are influenced by the narrowband colors, and I want my RGB colors. Plus, I want shorter exposures and tighter, smaller stars that more clearly reflect what they actually look like. So I don't want the bigger bloated stars that comes from the 240-second exposure. So I shoot my stars separately, and when I go into processing, after I have worked on the stars as a single image, then I remove the stars from the background, and I just keep the stars ready to combine them back to my narrow band image. And I also have to remove those stars so I can replace them with these tighter, more colorful, true to color RGB stars. You don't have to do that. I don't think I started out doing that on all of my images, and then I stopped doing it because I got lazy, because it's a lot more processing. And particularly if you drizzle, and I have to drizzle with this particular setup. And drizzle just means that I have to use an algorithm to add pixels where there isn't in order to increase the image scale. And I have to do that because I don't have enough pixels. My stars become real blocky looking because they're so small. It's like little pixel blocks, which is what they are. Pixels are square. So I have to get my round stars, I have to drizzle 2 times. It really makes the image twice the size. It does, it does. So we're at 71 images. We're waiting to get to 80. And then we're going to have a filter change. We're going to go and it's going to move to the O3 filter automatically. And the new event will automatically take place. It'll refocus and we'll start taking the O3 images. And there's 4 hours of imaging time roughly left. So last night I had 40 images of 240 seconds, and I was able, and 40 images of O3, and I was able to get this much signal. So I hopefully will have clouds allowing twice that signal. In fact, I'm going to take 90 in all, 90 images of O3 because the HA is dominating everything. And I need more blue. The blue I'm getting in here, it's more of a teal color, and it's a beautiful color. This is a result of a supernova explosion that happened between 5 and 8,000 years ago. And it scattered this dust. It's about a 60-degree, no, what is it? It's not that much. I don't know. It's trying to think of what it was. Tell you what, we'll find out. While we're waiting on all these images to take place, let me go back to All right. Yay. Now that's not where I want to go. We want to go to NGC 6974. And I don't mean to make you sick here. Let's go over to the northern. Here we go. This is northern meridian. And our target's right up here. It just crossed the meridian. And that's why this line right here is the meridian. And so 6974, where are you? It should be almost up here. There it is. Here it is. So, and of course, this is what it looks like. This is what we're imaging. This is that bright star I was telling you about. It's we want to go to the data, and it is 45 arc minutes by 30 arc minutes. It's a huge swath of the sky. As a matter of fact, when I chose this target, I'll show you something that's pretty cool here. When I'm picking a target, let me get rid of this for a minute. Oh, by the way, this is our first image. Let me stretch it. Can you see it's upside down? Let's go back. And let's go back. All right, that's when it flipped. So that was before the flip. And then we'll go look at the next image, and that's after the flip. And so when I stack all of this together, well, I'm not stacking it. When PixInsight combines these pictures, it accounts for the meridian flip, because all of these are dated. They have dates embedded in the file, so it knows exactly what's going on. Oh, my means come down from 1600 to 15, and that's just because I'm getting better signal. It's higher in the sky. It's almost at the zenith. So I'm not shooting through low horizons. So I've got much better signal. My half flux radius is 0.83, and that's because my guiding is going pretty decent. My guiding is at 0.88, and my RA is at 0.56, and my deck is 0.67. So they're pretty close together, so I'm getting round stars. And that's good. I don't have to really fret it that much when I take 10-second pictures, 10-second exposures for my stars. But this also affects, when this is good like this, then my target is good. So even though this shows me tight stars, good stars, it also translates into a better, more detailed image. So you want that. All right, I was going to show you this. When I pick a target, I'll go to Tools, and I'll choose Framing and Mosaic, and this is using PixInsight, and I'll type in the target was 69, oh, wait a minute, NGC 6974. And I use a field of view of 5 degrees with this. I'm going to add another degree, and I'm going to fetch it. Don't pay any attention to this message. That's a glitch in this software. Just ignore it and keep fetching. Keep fetching. Keep fetching. Now let's change this back to 5. Keep fetching. It always works. All right, let's try again. Wait a minute. Requires an internet connection to fetch the canvas. We've lost our, that's our problem. We've lost our, no, we haven't. We don't need an internet connection. All right, let me do this. Let me just browse to the Veil. Let me go to one of my pictures. I'll just bring up, I don't want the 10-second picture. Let's go to one of those pictures, and let me get rid of it, and then let's fetch. Oh, the whole thing's acting up now. That's crazy. So I brought in the image, and it reads the RA deck, and it should, well, let's go back up and try this. Well, I do have an internet connection, so let's try it one more time. I hate going live sometimes. Well, this is going to give me something to post and complain about. Are you kidding me? I don't want to. You can type in the RA and deck address. I don't want to do that, but bums me out. Well, and it's not because I'm imaging. It has nothing to do with it. I've created targets. Well, we've got an internet connection. It's right down here. Andromeda. I got a 5G connection. Not a great signal, but I've got it. Yeah, I ain't gonna try anymore. But what it will bring up a picture. You'll pull it off of a catalog. It'll bring up a picture of the target, and then I will frame it the way I want to take it, and it'll set up the sequence for me. It's pretty cool stuff. But at any rate, let's go back to. We're down to 7 more images in HA. I better head over and see what's going on with Jupiter. Okay, good. We're still centered, and I don't know how many we captured, but we'll wait this out. You have a live view of Jupiter right now. Earlier in the evening, we were imaging Saturn, and last night I took a picture of Saturn, and this is what I got from last night's work. So let's head back, and hopefully I also got some good Jupiter pictures. I'm not sure they're on this computer. I don't think they are. They might be, but I don't think they are. We're down to 4,900 frames. We're about to finish. Okay. Oh, we're going to 10,000. That's right. I did 5,000 frame AVI files for Saturn, and we did 8. I wanted 10. I like to use 10 when I derotate. It's just my thing. I don't think it has any. There's no real reason to do 10 other than that's what I like to do. While we're imaging, I'm going to the seeing has been pretty good the last 2 nights. I'm going to move my focus back in a little. We had a PhD correction just then. There we go. Okay, I'm going to wait till this is over. I want to see how many we've taken. We've only probably taken 3 with 7 to go. I should have timed how long it takes to do. Okay, 5 remaining. Oh, we've taken 5. Yes. I'm pausing 20 seconds between, or 25 seconds between captures. That gives me a little wiggle time to move them out if I need to recenter it. Isn't it amazing that we're getting light from this incredible gas giant? It's just crazy. My son sent me a telescope. About 10, 12, about 2009, I think it was. I had hip surgery, hip replacement. And actually, I got the telescope before that. And I've always been an amateur photographer. And when I retired from a 40-year career in financial planning, I started a photography business, mostly sports photography. But he sent me a telescope, actually ended up sending me 2, a Vixen refractor and a Vixen reflector, the 260L big Vixen 11-inch Smith Cassegrain on its own mount, and then he sent me a Vixen 81 EDS refractor on its own mount. And I thought these were heavy pieces of equipment. He lived in California at the time. I thought, what am I going to do with this? And so I had the surgery, and I was able to waddle around the house, but I wasn't working. So I set it up on the porch, back porch, the refractor, and I tried to operate it without reading any instructions. And of course the telescope didn't move, and I couldn't find the hand. I couldn't figure it out. So I had to read the instructions. And the first time I looked through it, he sent me some just Vixen eyepieces that are just, wow. They're really good eyepieces with this. And when I saw the moon for the first time, I liked to wet my britches. I went and got my wife, and I said, you will not believe this. And she came out and she looked through. She says, all I see is dark. I said, no. I looked through it, and all I saw was dark. From the time it took me to go get her and bring her out, the mount wasn't wired. I just figured out how to move it and get it on the moon. Well, the moon moved, Earth moved, and it was gone. So I had to go find it again. That was a struggle. You would think, looking up in the sky and seeing it, and looking down the barrel of the mount, you could go right to it. Not. It ain't that easy. But I found it again, and she looked through it, and I was hooked. And I thought, I got to figure out a way to put one of these DSLRs I have on there. And that's when I started my Google search, or I think it was Yahoo back then. And I Yahooed my way to, what was his name? A YouTuber. I think he's Japanese, maybe Chinese. Brilliant, did a great job, and he introduced me to astrophotography. What is his name? He did such a good job doing YouTube videos. He didn't smack his lips like me, he didn't hee-haw around. He just said what needed to be said, and he didn't say anything else. But I figured out what I needed, and I got it. And I hooked one of my Nikons up, and I took a picture, and wow. By that time, I read everything I could read about the mount and how to work it, and I was getting better at it. And I'm hooked. I was hooked. Then my very first Galaxy, I had a Nikon lens that it was a pricey lens. It was a 200 by 400 f4 lens, and it cost 3-4 times more than any telescope I own now. Great glass, good sports lens. It's like the f600 f4. It's just a terrific sports lens, but it's also made a terrific deep space telescope. And I found adapters from a company called ADM. They helped me build adapters that put it on a Vixen rail, and that was a very wide field setup, much more so at 200 millimeters than the 625 millimeter Vixen. And I was going nuts taking pictures. And I took a picture of, I took Andromeda, processed it in Deep Sky Stacker in Photoshop. And it's still one of my favorites, and it's still one of the best images that I ever have taken of Andromeda. I'm going to go find it real quick because I keep it fairly handy. Let's go to my desktop. Let's go to my Ecamm Live. That's my software that I use. And that's the print. And open with preview. Here's the best Andromeda picture I've ever taken. I think I overprocessed this one. And this was taken with the Nikon 200 by 400 and a Nikon D800E that I had modified by Spencer's. But I took this first, and then I had it modified by Spencer's. I went ahead and got the Nikon DA10A, which was a waste of money, the astronomy camera, but Nikon came out with. That I don't use. Spencer's did a much better job of adding a hydrogen alpha filter and removing the anti-aliasing filter. But at any rate, that was my pride and joy. I sent that to a photographer friend, Ken Tony, and he didn't believe I took it. And I was pissed off because he didn't believe I took it. I wanted to choke him. So it's one of my faves. We're capturing again. We're getting down to the wire. We are live imaging Jupiter, and we are live imaging the Veil Nebula, NGC 6974. We're taking hydrogen alpha and oxygen 3. If you're just joining us, I'm using Sequence Generator Pro. This is my software for acquisition. My mean has now gotten to 1493 from 1600 because the lights are being turned out in Spartanburg. Light pollution is less. My sky meter reading will have gone up. I'm in a class 6 Bartle sky, and but when it moves up from say 1860, 1870 to 1950, That's huge for me. So this is terrific. I'm getting good signal to noise ratios, and this is a much better image than when I first started, because the telescope is straight up and it's not shooting through those low horizon atmospheres that are reflecting heat from the sun during the day off of rooftops and streets and stuff that causes all that thermal dispersion in the sky. So this is my signal now that I'm getting. And my half flux radius has gone from 0.83 to 0.82. The smaller the better. That's really great. I'm looking at my right here at my median and my mean as I move over here. Over this star, the mean goes up to 7532, but the dark sky, the black sky is what I'm interested in. It's like the background. And let's zoom up a little bit. We get on the background where you have your signal to your noise, and it's down around 1493. I wish I could get it down around 1000. 1500. I'm going over stars. Right here is where I'm reading it. Then if you get here, it's 29, 7000, saturated. Okay, let's fit to screen. Let's do a low stretch. And this is how the sky is showing now. I love it. Let's go back over to our live view of Jupiter. Hello. We're at 6,500 frames on this particular AVI file. I'm shooting with a gain of 235 and an exposure of 27.2 milliseconds. I'm kind of bright. I could lower this some and increase my frames per second. In fact, I could raise the gain up to 250. And it's not going to create that much more grain in the image, and lower my exposure to around 20 and milliseconds, and I could get this up to maybe 35, but it is what it is. I'm going to, we had a correction. You saw that jump? Watch this. We'll go down to PhD. Look at this big jump right here. That's what we just saw. Bingo. Wonder what caused that. That's a declination adjustment. See where the pulses started? They sent one real quick to bring it back. It was about to go in one direction, and then the mount sent these pulses to correct it. And that's why you saw the Jupiter go jump on me. That was an 8 arc second. I think it was. Let's go back. Where are you, Jupiter? That went up 8. That went up, 10 arc second correction. That's pretty, that's radical right there. I don't know what happened. I wonder if I have bats outside landing on my gear. I don't ever just sit and watch my surveillance cameras, but I need to do that sometime and just sit and watch this and see if something lands on this at night. You would be surprised how many things end up in my yard around 3 and 4 o'clock in the morning. And we're in suburbia. We've had bears in our neighborhood. But crazy stuff. Well, of course, rabbits come. but nothing's going to happen while I sit here and watch it. It looks like I've got lights on in my backyard. I don't. I'm using infrared light, and it lights up my backyard, but it's pitch black in my backyard, relatively speaking, to the light pollution that I have. But I have a street light right here, and that's why you see it on the side of Dagmar's house. Now the weights are going down now. They were horizontal, but the mount's going up. I mean, the telescope's going up, and the weights are going down now because we've done our meridian flip. Back to Jupiter. Live view of Jupiter streaming in. I'm going to do this again tomorrow night, but I'll have a different target. I don't need more than 11 hours of time on the Veil. If I don't have a lot of color, then another 5-6 hours isn't going to make, I don't think, a whole lot more difference. So 11 hours ought to be a gracious plenty with this kind of scene and this kind of good guiding. But I am going to continue to gather files on Jupiter and on Saturn and Mars in a month or so. It's nothing short of spectacular. We ought to be getting close to changing filters. We have 2 more. Let's see, we have 26 seconds left on this one, and we'll stay with this one. And then, let's see, we'll have 1 more image to take in 6 seconds. And then you'll watch how this moves from this event to this event, how we change filters, and then it will refocus. So we're getting ready to start. We have 79 images in the can over a 2-night period, 80 total. 240 seconds each of hydrogen alpha. We've got 1 more left to go, and then it's going to change filters, and it's going to stop guiding, and the software is going to do all of that. I'm just going to sit here and talk and play my little song in the background. Do 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 do. I've got to get I've got a bunch of them. That's the one I have on my stream deck. I need to put some more. I guess I do. This is the longest I've ever gone live, ever. I started at 9:15. So this is 2 hours of streaming and taking pictures. There's not anybody in their right mind is going to watch all of this unless you're just absolutely lost and bored stiff. But I like doing them. I love doing this. Oh, I found something. Let me see if I got it. I don't. Oh, yeah. See if this works. I'm going to hit a button. Nah, doesn't work. Oh, it did work. Hit it again. I like my little... I did that. I made that. Ding dong. You're supposed to like this and subscribe. And I really don't... it doesn't make me any difference. I enjoy doing them. From time to time, somebody writes a comment that was very helpful. That makes me feel good. But I'm passionate about astronomy, and amateur astronomers, I think, all are that way, and I enjoy sharing it. I I absolutely probably drive people crazy because they'll start up a conversation with me, and the next thing you know, I've got my iPhone out showing them my website and pictures I've taken, and I know a lot of them don't even give a rip, but they're gonna. But I'm an old man, so they feel obligated to listen to me. You get by with a lot of things when you get in your 70s, probably 60s. Sure. It's hard for me to say 78 years old. It just I don't feel it. I do a lot of working out still. I've always walked, and I've always been able. My offices were always very convenient to a gym. I can't do it anywhere else. I have to go to a gym. But we have a Planet Fitness that I go to. It was a Gold's Gym, and then now it's a Planet Fitness. I was at the Y forever. My offices were almost across the street from them. But I'll walk 4 miles every day of my life, including Sunday. And I do it on a treadmill, watching movies with an iPad, YouTube videos, stuff like that. I get tired of, uh, oh, there's some tremendous universe uh, videos on YouTube. Just tr- and on Netflix, they've got Neil deGrasse Tyson's. All of his are on there. That okay. I was talking, and it changed it to O3 over here, and we finished that image, and now it's autofocusing, and so it moved to O3, and now it's running uh, a focus routine. So it's taking a picture. It's going to defocus the telescope. I'll move this over. So it defocused the telescope intentionally by 80 steps. That means 80 steps. It racked it out 80 steps. The focuser, the draw to, went out 80 steps. Now it's going to move it in, I think 15, and take another picture. So the stars are going to get better. They're going to get smaller. It takes an 18-second picture because these are narrowband, so they got smaller. And so this line is pointing, the lower the better. So the half flux radius, remember I was at 0.82? Well, it's at 0.8 something here. I mean, it's 8 something, not 0.8. And now it's down to about 7. So it's going to, and these are the focus steps from 76, 86 to 84, 86. So the next picture it took, it's gotten even better. So it racked it out. Now it's racking it in about 15 steps at a time. And then it's going to reach where it started from, where it was prior focused, and it's going to rack it in the other direction. And the line's going to defocus again. And where those two intersect is the absolute best focus point. See how the stars are getting sharper? And my half flux radius is now 2.83, 3.07, where it was 9 up here. 8, 9, 10. So it was about 9, then it went to about 7 something, and then it went back to 5, and now it's back to 3. So now we're going down to 1.2, and it's recommending that I be at 80, 86 steps, and with a quality recommendation of 100%. So within 100% margin of error, 8086 is going to be my new focus point. I don't know where it was before. Daggone, I should have looked. It will be different than the HA. Now it says my margin of error is going to be around 99% quality guesstimation with an AFR of 1.8. It'll get better than that. So it's going to start going in the other direction. And it racked it out and it started coming back in. Now it's going in the other direction, defocusing. So, and it's taken, I think, 18-second exposures so that I'll have enough stars. And this is a crop. Uh, I crop in a 5%. I don't want to use the stars way out here because they're never real round anyway. I don't want to use those for focus. I need to crop in about 10%. Okay, we're taking another one. It's recommending now that the focus be set at 80-45 with a quality margin of 97 at 80-42. That's the new recommendation. HFR at 1.6. And so it's happy now with this one. So it's taken a validation exposure. So it's going to validate the stats. And if it works, then it's done. It worked. It's completed. It asked me if I want to run it again. No, I'm happy. It says I have a half flux radius of 1.03. I will go ahead and tell you that's good for the O3 filter. It's not parafocal. None of my filters are parafocal. And so that's a good rating for that. I'm happy with that. I am. So it settled down, and now we're taking a 220. It started guiding back up again. So guiding has begun again. I'll clear that out, and we'll clear that too. So we're at 0.47. RA and DEC are at 42, 30, 40, 30, 29, 38, 28, 38. As long as they're close together, 28, 36, they're a little too far apart for me, but 31, 37, that's better. 33, that's a little better. 32, 40, 32, 40, 33, 39, getting better, getting better, getting better. Sharp stars. So my HFR on the first image ought to be even better than 1.06. Let's go see. This is 0.83 from the HA filter. That was on our other image. So now it's moved down to the O3, and we're going to take 50. It's going to take us 3 hours to do that. It actually takes longer than 3 hours because there's this time that it focuses with every 2 degree temperature change, and you saw how long it took to run that focus. Plus, you also have dithering that takes place and a 10-second settling time after that I build into the system. So you have to add another hour to this. So it'll be 4 hours plus before it's all over. And right now it's 11:33, so it's going to be around 4 o'clock when this all stops. And then it will automatically shut everything down and park the mount where it's supposed to be. The only thing it doesn't do is put the cover on it. I'll be asleep. I'll do that in the morning. But it keeps the dew heaters on all night. It shuts the power off to everything else, the Pegasus does, but it keeps the dew heaters on to continue to keep the moisture off of my telescope stuff. Pretty cool. Okay, we'll go take a look at Jupiter, and we're now capturing, I don't know how many frames we've captured, how many AVI files we have, but we're taking 10,000 frame AVI files if you're just joining us. And I imaged Saturn around 9:15, 9:30 to 10:30, maybe to 11, and then to 10:30 probably. And we've been on Jupiter since probably 10:30. So I should have some pretty good images, pretty good data. It's a good scene for us. Pretty good scene. This is what I took last night. My image of Saturn from last night. So Jupiter was even better in my opinion, but it's on the hard drive. It's still on the hard drive that I have connected to my outside kits. I have these real little small 1 terabyte hard drives that are about the size of oh, a GoPro battery. If you're familiar with that, not as thick. They're real thin, and I Velcro them onto the side of my kit and plug them into the Pegasus power box, and so that's where all of my data is stored. And then I just unplug them, bring them into my big iMac, and or I have a laptop right next to me that's a Windows 10 machine, because most of the software, unfortunately, that I use for I say unfortunately because I don't like Windows, but most of the software that's free is written in Windows or Unix, and so I have to have a Windows laptops to run it. But I'm not complaining; it's free, and but I operate off of Macs, and I'm on a Mac right now, uh, connected to my Windows machines by way of Wi-Fi. And those machines are outside. I have a laptop for each telescope. There's 3 telescopes outside. Let's go back to this. There's a table down here, and I have a towel thrown over it, but there's 2 laptops there. And then this is a solar kit covered by this telegizmo, and underneath it are the telegizmos that go over these kits. I just wrap them up and put them underneath this. But there's when I'm doing solar imaging, I just use the laptop that I have for this particular kit, and I connect to this and use this tabletop. This tabletop is built in between these 2 piers. And then there's a wall right behind this that I sit on. It's like my own chair. So I can sit there and work off of these if I'm outside. But I'm not outside much. I don't like mosquitoes, and I don't like cold. So in the wintertime, I'm inside. And this is my home. And it goes 2 stories over here. And I'm upstairs all the way to the front. So this is as far from the front of my house on the corner. I'm on the corner. This is as far as I could possibly get, not by intention, but this gives me a 365-degree view of the sky from about 18 degrees up. Can't get any better than that. And you can't tell, but this is up on a hill. Well, you can see how the fence goes up. But this is up on a hill, and it's actually pretty much level with the top of my house when you're standing up here. And then I have a fence right behind me, so I'm not worried about thieves, and the gates lock up. I'm just not worried. If it gets taken, it gets taken. I'll file insurance, and go buy some more equipment, or take up another hobby. So let's go back to Jupiter. And let's see, we're at 7,000. I'm going to wait till 10,000, and I want to see how many I have left. But I'm about ready to sign off and go downstairs and get some more coffee, is what I'm about ready to do. And it's about what I'm ready to do. It's not smart to drink coffee at 11:39 at night, but I drink it 24 hours a day if I could. Bad habit. But on a brighter note, there's not an alcoholic beverage I've ever had that I can honestly say, hey, I like that. Well, maybe one. But I wouldn't know how to make it. White Russian. That actually tasted good, but it made me sick. Okay. Do 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 do. We're at 9,500 frames. 97. 98. I'm curious to see how many I have left. We finished. We got them all. All right. I'm going to process one for you, and then I'm going to sign off. So I'm going to go ahead and park this telescope, and I'm going to click on park. Well, first I'm going to turn the camera off, and now I'm going to park the telescope, and I'll go outside, and this one right here is going to park, and you'll be able to see inside this telescope because my observation camera looks right inside it. It's going to turn around and look right at us, and you'll see all the mirrors in here. Well, oh, I got the, never mind. I have two observation cameras. I got the wrong one on. Not, it's just, I've got one further on down that looks more up in the sky, and it's okay. I don't even, anyway, that's now parked and turned off. So what I'm going to do though is get out of Real Link. Let me go to it's parked. I'm going to unpark it. I'm going to close out of SharpCap. There's my now my guide camera's looking right in that IR scope. So I'm going to clear this. I'm going to stop, and I'm going to disconnect this gear, and I'm going to go ahead and exit. I'm going to go up to telescope. Well, I'll come down here. I'm going to disconnect my mount, and then I'm going to go to Cortez de Sul, which isn't how you say it, it's how I say it, and I'm going to disconnect. I already disconnected the mount, so I'm going to turn that off. Yep. And then I'm going to disconnect EQ ASCOM, my driver, and then I'm going to turn off the focuser, the mount. I did the camera. I'm going to leave the dew heaters on, and I'm done with this with one exception. Let's bring up Auto Stackert. I think I got it. Well, I don't. I may not do anything then. Huh. I thought I had. Huh. I thought I had Auto Stackert on this computer. Let me go up here and come down to C drive, program files. I don't guess I do. Let me go to Windows. Let's look at more apps. Nope, I don't have. Well, I'm not going to process it after all. I was going to process that image, but I don't have Auto Stackert. I need to put it on that computer. But crap. Doopy. Okay. Well, I don't have it on there. So we are done with, let's just at least do this. Let's bring up, see, we need to bring up the external drive, the little 1 terabyte drive, and planetary today, and today, and this was our Saturn shot we took earlier. Let's just pick a Saturn AVI file, and there's Saturn. That's the video that I took. It's a 2-minute and 38-second video, and you can scrub through it. And I will process that auto-stackered IMPPG and RegiStacks sometime tomorrow. I also like to use Castrator if that'll open up. I don't think it will. Nah, I think it's been deleted. Castrator resizes the dark sky so that you eliminate a lot of the unnecessary. You don't need to see a lot of dark sky, and so it kind of crops into a video file. It does a video crop, what it does, and a debayer. Okay, we are finished with that laptop, and we are back over now to say goodbye ooh, look at this messy, look at this RA. It jumped to 990. What happened? So, all of a sudden, the guiding went incredibly bad. Let's raise up the guiding from 1 second to 2-second exposures. That image will not look good. Let's bring up that image. And has it finished taking 80 seconds? So let's wait and see what that image looks like. This is the last image before the guiding went, before this happened. This one I'll have to, this next one will be, as long as the RMS error doesn't go greater than my image scale, which is 2.32. My image scale is 2.31 right here. As long as my RMS right here is less than 2.31, I can use the picture. I don't have to delete it. Oh, looky here though. This isn't real good. My RA is in almost 100 and my deck is like 50. So I'll have some oblong stars with it being that far apart. So either scene conditions have changed that's causing this. I don't know. And what happens when scene conditions go crazy is that your guide star is moving around due to scene, not to mount issues. So it has nothing to do with your mount, but your mount is seeing the guide star move because the scene is pitiful, and it's trying to send corrections to fight scene. It can't. It can't. And so when you have a star that twinkles, when you go outside and the stars look like they're twinkling, that's a good sign that the scene is not good. Your stars ought to look like a non-twinkling point of light. Well, it's gotten better, and I don't know what happened. Sometimes it's unexplainable and nothing, no snag, no cable snag, no anything. It just, it got hung up the gears or some friction, stiction or something caused it to stop, and then it started back up. And with that, it doesn't take much. By the way, if a car goes by with one of those radios that has that very deep bass, I can see it change my guiding. And I don't hear it inside my house, but if I'm outside with the telescopes, and we live, streets are in front of me and to the side of me because we're almost at a corner, and he doesn't live there anymore because he's graduated and gone on to college. But he had one of those radios, boom, 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 and every time it did that, this thing would bump. So these are sensitive pieces of equipment. Doesn't take much to move them. Okay, but when you're focal length, when you're looking at something, have you ever looked at the sky with a pair of binoculars and you just can't hold it still enough? The moon, for example, you're trying to hold it still and you just can't hardly do it. Well, you've got to hold a telescope still to take pictures, and any breeze or movement or the bass on a car radio can screw stuff up. So don't fret if your mount starts making those kind of crazy, unexplainable. Your mount's probably just fine. It's just life. Life is happening. So, all right, let's see what that image looks like and then go home. Oh, wrong way. Don't need that either. Ah, let's zoom. Look at these stars. So that's what happens. Now, you can't really tell from the nebula. You know, I'm going to remove these stars anyway. That's why I take the tight star 10-second images, because all these stars, even on the good images, are going to be removed. But this is one of those where you mark as bad, and so it gets automatically removed. And it happened again. Look over here. It says event warning. Distance was 5.1 pixels. So I may have to go out. I may have a cable dangling that's causing this. So it's a good time for me to sign off and go outside and babysit the mount for a minute, see if I can't figure out what's going on. All right, let's fit this to screen. You can see where I've marked it thumbs down. It will be automatically deleted. It's as though I never took it. And so I've got a bunch to take. Hey, look at my mount. Look at my guiding now. It's gone 16.75 RMS. Look at this, 17 by not 63. And you got to understand now, nothing's happened except probably a cable. This pretty much tells me that one of the cables is creating some issues. And well, folks, I'm going to bid you good night. I hope you all have a great week. I will be probably back live again tomorrow night. I'm going to be imaging tomorrow night, whether I go live or not. And I like to go live when I image. I feel like I'm sharing it with friends. And for those interested, and hope you have a great rest of the evening.